Hey there. Let's do some analysis in Excel and use as many functions as possible. So let's create some data. So we're going to have some data about people, and let's just randomize the data. So let's highlight these cells here, click in the little corner and drag down to autofill. So let's have a sample of 25 people. Another way to do this would be to start this with 1 equals plus the cell up 1 plus 1 and autofill that down. Same exact thing as autofilling. And what should we track about these people? Let's have a hair color. Let's have an occupation. Let's have an income. We can track their height. And what else could we track? We could do country of origin. Alright, so we want to randomize the data set. So one way we can do that, I'm going to call this sheet here lookups, double click on it, right click to double click rename, or you can right click rename tab color if you want to change the color. Let's make the lookup sheet blue, drag that over. So what are we, here's our master list. I can't see that far. Okay, so we need hair colors, so let's go hair color ID, and I don't know, let's have how many colors do we want? Blonde, brown, gray, white, black. I'm not going to do any synthetic colors. I don't think there's too many. Is that all of them? I think those are the main ones. So let me just recolor this one. We'll make that red. So hair color, we want to assign each person a random hair color. So here's how we can do that. VLOOKUP, we're going to look up a value in another table to find a match. So we're going to VLOOKUP a random number between, so VLOOKUP a random number between the maximum, bottom first, I'm sorry, minimum of our hair color set here. Select the range of cells, press F4 to lock it so that it doesn't, the reference doesn't move. In the top, I feel like I'm forgetting something here. Oh, no, nope, we're good. Max of the same thing here. Okay, cool. Alright, so we've got we should be getting a random number. I don't think there's a typo in there, but I guess we'll know in a few minutes. So VLOOKUP a random number between the minimum and the maximum of this range here. And then we will want to, oh, I did forget something. What did I forget? Oh, there's an extra parenthesis there. I wonder why it did that. Oh well. Okay, so there's our top. And now we want to look it up in this range here. And again, we can lock it. Our column index is going to be 2. This is column number 1, which is what we are joining on. And then we're looking up the second column here. And we want exact matches only. False. Let's see how we did. So if this works, we should get a randomized hair color, brown. And let us autofill this down. Now, here's something, a fun fact. If I change any cell, these will all update. the way the function works. So see, brown here for row number 2, gray row number 2 when we make a change. We'll keep changing these until we fill out the other randomized values, but occupation, let's make this more general and just do, are they an office worker, a factory worker, or like, you know, an industrial worker, retail, civic, self-employed for now. Try to keep this simple. Industrial, retail includes food and restaurant, civic, and self-employed. Okay, now we can do the same basic thing here. Let's see how well we can do. Yeah, I know it's changing. It's B6 to B10. Let's change that to E. So we want this to be E on both. So E, 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 E. Ooh, no. E to F. Boom. All right, let's see how we did. Perfect. Industrial. Good. Okay. Now, obviously, these are randomized, so we're probably going to have, you know, close to 1/5 of people in each bucket. I think there's 5, right? Yeah, 5 buckets. So, but, you know, just because I didn't want to make this like a 20% for everything. So, income, let's assume everybody makes between 18,000 and 125. Okay, and let's round that number. So we're going to nest another function. Let's round up to the minus 1. Okay, maybe minus 2. It's a little too much. That's better. So we're rounding to the nearest 100 here. So rounding up a random number between 18,000 and 125,000 to, you know, making the right 2 digits 0. So we don't care about the tens or the single digit. Height should be normally distributed. I don't really want to do that because I don't know. I mean, I guess there is a way I could do it with a similar function, but let me think about how I want to do this, because I don't want it to be equal probability. It should be, and same with the, I guess really the income should have also been probably like normally distributed, but that's okay, because, you know, it's probably not as likely for somebody to make 18,000 and 125 as 40,000, but that's okay for this example. It's all right. Height. So let's see how we want to do this. Let's say, and we're not including sex in this, so, you know, because obviously by sex the height will vary, but let's just assume a global average height of 5'8", just to make this real simple. Okay, let's do. Alright, so this one will be 5'8". It's the average, and let's say, so we got 10 here, so let's assume around 50% of people will be 5'8". 10%, 5'10". No, 5'20". Okay, we're going to assume just okay, here's what I'm going to do. 5'6", and then 6 feet and 5'4". Okay, There we go. And then we're going to do I6 to 16. Okay, perfect. Okay, I6 to 16. I6 to 16. And look up I2. J16. Yeah, 16. Okay, let's see how we did. Cool. First person 6 feet tall. Look at that. Okay, so obviously it should be 5'8" should be the most common height. And then country of origin, let's just assume everybody's from North America. Always label your columns. Okay. Country. Okay. Okay. Boom. All right. What column was? Should have taken note of what column that was. That is L and M 6 to 8. Okay. L and M 6 to 8. L 6 to 8. L6 through M8. Perfect. All right. So we now have a randomized data set. Let's highlight everything, and we can paste this value to keep everything static. So we're, ignoring that randomized change all the time. This is going to drive me nuts. So click a number, change this currency. Everybody, these are incomes in US dollars. So we'll do it like that. Income USD. Okay. So now we have a set of people with some attributes about them. Let's go here and do some analysis. Now, let us assume that person number 5 wants to invest some money. Let's figure out what their income is using a VLOOKUP. We want to look up the income of person number 5. I'm going to cheat, highlight the whole column. We want the 4th column. We can also use an index match if we make this into a data table, but okay. They make $29,300 for their annual income. Let us assume they are able to put money into, let's assume they are able to invest investment rate. Okay, so they can put, I don't know, maybe 5% of their paycheck, 5% of their income toward investment. So we can use a future value calculator for a simple estimate of how much money the investment portfolio could be worth. Let's assume, I forgot to include age, but let's just assume this person is 25. No, let's say 30. Say they're 30 years old. Future investment value with a simple straight-lined contribution. Their rate of return, first parameter here, 5%. They are investing for let's say they want to retire at age 60. Okay, ooh, and I'm sorry, I confused myself there. This is the percentage of their income they want to invest, and they need a rate of return. So, annual investment. Okay. There we go. So again, driving me nuts. Okay. So putting $1,400 away, $1,500 almost. Okay. Now they have a nominal rate of return, and we can adjust that for inflation. So let's assume they make 7% on their money. They want to retire at age 65. Okay, so rate of return here, nominal, means before inflation. So 7% nominal return for 60 minus 30, their current age. Their payment is going to be $1,400, $1,465 per year. This is all annual. We'll assume it compounds annually for simplicity. Let's assume they have no money to start with, starting from 0, and then we can, just so that it's a positive, so a person making $29,300 who invests 5% of their gross income, earning 7% per year for 35 years, yields $138,000. We found that using a simple future value calculation. But let's assume this person, well, one, we can do the same exact thing with a inflation adjusted rate of return. So take the nominal rate here. Let's assume 3.5% inflation that whole time. 0.035. Okay, so in real dollars, 75K of real wealth after inflation. Let's assume this person, well, in one way to think of this is this setup would be true if person 5, their income grows in line with inflation, right? Because they're putting the same real amount of money effectively into the investment. Let's model something a little bit more sophisticated where here's the income. Let's assume this person earns 4%, gets a 4% raise per year. So this times 1 plus 4%. And let's assume this is age 30, 31. Okay. And we're going out to 60, I think. So 60, okay. Format painter to get the same look of the cell. Alright, so here's their income over time. Let us assume they can invest a straight 5% each year. Oh my gosh, times 5%. So here's what they're putting in each year. Boom. So goes up over time. Rate of return. And let's do this in terms of, let's do the real rate. So 3.5% real rate of return. Right. So essentially what we want to do is for 30 years, this money will make 3.5% real. This money will make 3.5% real each year indefinitely. So we have a real rate here. Yeah, that's a rate of return, 3.5, lock it. Now here's how we can do this. 65 minus the value there to get the period, and present value this time, because we're effectively starting with a lump sum and we're keeping it, you know, for 65 minus however many years we have. So, okay. So, of the 1465, by the time they retire, this money turns into 4883. So let's do that for each year. And then we can take the sum of the total here, the row total. So it yields 162,000 instead. So, you know, here, the person is making making higher contributions in real terms each year, so that the value, that their income is able to stay ahead of inflation. So you see it yields a higher return. So this person might start making 29,000, but you know, over time, eventually they're making, oh god, that's a big increase, 4% increase gets up to 95K. So, for what that's worth 30 years from now. It's the power of inflation, or, you know, currency change. Okay, well, enough of that. Now let's look at a proportional distribution of people by hair color. So let's insert a pivot table here. Oh, I don't like that. I don't like that. Okay. So, hair color in the rows. Oh man, you know what? We're not going to use a pivot table. This is making me mad. Instead, pivot tables are really easy for that, but I did the same thing there. Alright. Wow, for real? I gotta default that. Okay. So, okay. So let's see how many people can use a COUNTIFs. So we want to count the rows if hair color, don't have anything else there, is equal to this value here. Oh my gosh, is that right? Damn, this is one of the very skewed. Okay, was not expecting that. So, right, we can get a proportion by dividing the count here by the sum of all counts. So, 56% of people have brown hair. Damn. Okay. And another 24 have black hair. And I people always told me black and brown hair were the same. So, I don't know. But 80%. And if we sum everything here, you can see in the corner here, sum 100%. So, damn. That's kind of crazy. Let's do the same thing for occupation and country of origin. So, I really don't want to do this. You know what? Instead of doing that, there we go. And then height, it better be 5'8". I'm gonna be annoyed as hell if it's not. Apologies for the white cell. And I don't like that being. I have an issue with that. Okay. Okay. Now, I don't screw this up. This should be the next column over. So we change that to E. Perfect. Alright. So we've got most of the people working in industrial jobs. Well, plurality. No, actually, I'm sorry. Yeah, industrial. So pretty even there. Height. Wow. Oh, wait a minute. That is not right. It's G. Forgot about income. Okay. There we go. Okay. That really, I'm kind of surprised there. Damn. Okay. So I mean, it's kind of a bell curve, but not really. Actually, it's a terrible bell curve. Oh well, we didn't make it a bell curve, that's alright. And then H. This one looks a little bit better. Yeah, there we go. Pretty even, but, and I guess the count will always be the same, but just out of best practice. There we go, so pretty close there. Alright, so we've got our distribution. Let's get the median income, and we can do that by median and average income by, say, occupation. See who's making the most money. And this is mostly just to go over formulas for Excel. If you actually want to get this data, at least for the US, you can go to the Bureau of Labor Statistics and get the actual weekly wages by industry code, NICS code. NICS, basically, these are industries, so like 31 through 33 is manufacturing. Maybe we can go over that sometime, but okay, what was I doing? Average income. Now let's do this the old school way. So, aggregate income, let's sum the income, sum ifs. Let's take the sum of income if the occupation matches this here. I don't know why I locked that one, but not the column. Alright, so here's the cumulative, and we already know the number of people, so let's take average from that. This value divided by the sum ifs of the count here, number of people. Okay. What did I do wrong? What did I do wrong? Oh. Got ahead of myself. Okay, that's better. So, but this is... Can't do it. Okay. So here are the averages. So, looks like, so retail, lowest paid, civic, highest paid. Pretty well distributed though, you know, not too extreme. Let's get the median of these categories. So, alright, here's how we can do this. We'll use arrays to get it. So let's take the median. If, well actually here, let me show you how this works. So we'll do it by hand. We'll do it by hand second, but okay. So median, if the occupation equals this cell here, then we want to take the income, otherwise we're going to say NA, because we don't want it to be included in the median calc. So let's do Control-Shift-Enter, and it should give us a value. So here's the median. I want to check to make sure that's right. But, because in this case, our average is actually being pulled down by a couple very low earners. But let's see how it looks. Perfect, it's updating, so that's always good. Actually, a lot of these, the industrial, it's pretty well distributed, but retail, it's higher, the median's higher. Oh, interesting. Okay. I guess they made the dollar value skewed lower, so. Okay. Let me just show you. So, if we were to highlight these cells here, and let's just put them here for now. Let's sort this by G, and then H, largest to smallest. Alright, so civic. So it's the average between these two numbers. So 110, 100. Here's the proof. This value matches that value. Industrial, how many do we have? 8, so same deal. Oh my god, that's insane. This is insane. 73,250. Look at that distribution. You got 4 people earning 100K plus, and then you got 4 people in below 45. Wow, man, I made a terrible distribution. That's okay. It's okay. What else should we do? Let's make a unique identifier for each person. We can concatenate everything together. This is bad practice. What I would say is, oh, it's not going to let me do that because of the other. So, concatenate, save the ID. I always do dashes or the vertical bar when I'm doing it. You know what, the income we probably don't need to include, but it's fine. Okay. Let's see if it'll take that. So here is a unique identifier, like a key, right? So we're combining every single attribute about the person in one place here. So if you're interested, that's how concatenate works. It just combines. Watch if we want to just combine like these two columns together, right? Brown civic, drag it down, brown retail, etc. So concatenation, future value. What are some other things we could do? I'm just curious. I want to just see if there are any other fun formulas to try. Those are a lot of the basics. We did average, we did min, max, random, VLOOKUPs. I think that's good for today. So I guess we could do like one final analysis. Well, no, there's really no point. Okay, well, I hope you enjoyed this, and thanks for watching.